In this section, we'll discuss planning and design considerations for deploying your AVS private cloud. There's 5 dimensions of planning. What are you trying to do? Where are you going to do it? How much of it do you need? How are you going to connect to it? And how are you going to manage it? All of these are key when planning out your deployment for your private cloud. We generally talk about AVS aligning to 5 use cases: data center extension, cloud migration, disaster recovery, virtual desktops, and application modernization. Each of these use cases will have its own quirks, caveats, and requirements. But what we really want to look at today is how those use cases will determine sizing, placement, connectivity requirements. Most of the time, we're talking about some combination of the first 3. When we talk about placement decisions, we have to ask ourselves a number of questions. Do you have an existing Azure footprint? Is AVS supported in the regions where you're using Azure? What AVS supported region is closest to your existing data center or your users? And do you need AVS private clouds in multiple regions?
And next, we need to figure out how many hosts we need and where they're going to go. How many hosts do you need per region? Do you need multiple clusters for workload separation to limit blast radius because you need more hosts than might fit in one cluster, or any of the other traditional vSphere reasons for deploying multiple clusters? There are some maximums to be aware of. You're allowed 1 private cloud per subscription by default. That's a soft limit that can be raised by working with Microsoft support, but again, by default, 1 private cloud. You can have up to 12 clusters per private cloud. You can have up to 16 nodes per cluster, and you can have a total of up to 96 nodes per private cloud. Also, keep in mind that all the private cloud management components, vCenter, NSX Manager, HCX appliances, vSphere application appliances, if you choose to install those will all live on the first cluster and consume resources on that cluster. As Jeremiah said, most of the time we're talking about a data center extension, cloud migration, or DR scenario. And to determine sizing for these, we need to look at the aggregate resource allocation or demand of the existing VM footprint in the data center that we're trying to extend or migrate. And there are a couple of tools that are really good at doing that modeling. Microsoft tends to lead with Azure Migrate because A, it's their tool, and B, it's free. Azure Migrate can work in 2 different ways. You can deploy a lightweight appliance into your vSphere environment, and that will discover and gather performance data for all your VMs without installing an agent on those VMs. Or you can build a CSV file with inventory information. There's a specific template that Microsoft will want you to use, but you can massage an RV Tools output into their format without too much trouble. Either way, you import the data from the appliance or from the CSV file into an Azure Migrate project, and then set some parameters. You can project some sizing based on the actual allocation of resources or on the observed VM performance, the resource demand. You can set target ratios for CPU over subscription and memory over commit, set targets for dedupe and compression factors, and then Azure Migrate will generate a report that looks a lot like this one that shows you the number of AVS hosts that you need and their projected utilization after migration, and also give you an estimate of monthly cost. Another good tool is vRealize Operations. And if you have this deployed in your environment already, it makes this exercise super easy. There's a built-in what-if analysis report that does all the heavy lifting for you. It's the Migration Planning VMware Cloud report. You select AVS as the target cloud, you select the region you want to deploy into, and then you select the number of VMs to model based on their names, application, tag, custom group, or vCenter object or hierarchy. You have some assumptions you can adjust for reserved capacity and steady state headroom and vSAN fault tolerance, dedupe compression, and you can set an assumed annual growth rate. So it can take that into account when it builds the model. And then you run the scenario. That generates a report that looks just like this one. A bonus here is that if you choose to migrate these VMs down the line, all historical performance data will move with them and show up in vRealize Operations on the AVS side. Now, both options, Azure Migrate and vRealize Operations, will give you a number of hosts required, the monthly cost estimate, and the resource utilization after migration. Azure Migrate gives you a few more knobs to twiddle with, which is great if you want to play out different over-provisioning scenarios. vRealize Operations is a little more opaque, but it's using the vRealize modeling engine, past historical performance data. It doesn't feel the need to expose all those options to you. It just sort of gives you an answer. You need this many hosts and everything will be okay. Both options return a projected number of AVS hosts required, monthly cost estimate, and resource utilization post-migration. Either tool will work. If you have vRealize Operations Manager already, we would suggest that one, but both do the job. When you have your initial sizing figured out, we can talk about connectivity.
All right, so for connectivity, we kind of need to circle back to your organization's current Azure state. Is this your first time, or is AVS your first time, being introduced to Azure, or do you already have an existing Azure environment? If this is your first time into Azure, then you might want to start with a site-to-site VPN, and it looks something like this graphic here, right? So the AVS environment is connected to a dedicated Microsoft Edge. Here we have a single region deployment with a virtual hub deployed in Azure, connecting to both AVS via an ExpressRoute gateway and your data center via a VPN gateway. This is great for a proof of concept or for non-production workloads. And we used to have to stress that this was generally recommended for POCs, just because some of the add-ons didn't work great over VPN. So with a number of updates, we can say that that's not the case anymore. So with HCX migrations, this wouldn't have been supported previously, but now it is supported with a site-to-site VPN. That's provided that your connection meets the network underlay minimum requirements. And if it does, HCX over VPN is supported as of HCX version 4.2. If you're deploying AVS to utilize this as a target site for disaster recovery with Site Recovery Manager, an ExpressRoute is still required at this time. So just be sure to check the documentation and the requirements or the network connectivity requirements for the solutions and the use case that you plan to use. And we covered this in the previous technical overview series, but we'll just touch on it really quickly. We find that most of our enterprise customers have an existing ExpressRoute circuit between an on-premises data center and an Azure region. Using ExpressRoute Global Reach, customers can peer that ExpressRoute circuit with the private ExpressRoute circuit supporting AVS to allow for connectivity between on-premises resources and AVS.
So another common pattern we see is the hub and spoke model. In this model, a central hub VNet acts as a central point of connectivity. You then might have separate VNets supporting different teams, different projects, or specific use cases. And all of those are peered to the hub VNet for connectivity back to the on-prem DC via ExpressRoute. In this model, AVS becomes just another spoke connecting to that hub via an ExpressRoute gateway in the hub VNet. And ExpressRoute Global Reach then provides the transitive connectivity between AVS and on-prem. Similar concepts apply if you're following the enterprise landing zone multi-subscription approach. You'd have a child subscription containing AVS and connect that to a gateway in the connectivity subscription. Virtual WAN is another supported topology. Similar hub and spoke concept applies here. You have a virtual WAN hub configured in a region and connections defined for on-prem data centers and branch offices. AVS, again, becomes just another spoke by way of linking the AVS ExpressRoute to the virtual WAN hub gateway. You also need to plan for some non-overlapping network and IP allocations. You'll need a /22 block to assign to the AVS private cloud. The private cloud provisioning process will automatically carve this up into networks for private cloud management, HCX, vSAN, vMotion, ExpressRoute peering, and some other rainy day reserved ranges for future flexibility. You'll need a VNet to connect AVS into. If it's a new VNet, you'll need to assign new IP space to it. That VNet will need a subnet called a gateway subnet defined, which will host the virtual network gateway that connects to the AVS ExpressRoute. You may need additional subnets defined in that VNet as well. In our lab scenario, we're actually going to create 2 extra subnets there, one for Azure Bastion and one for a Jumpbox VM. More on that when we get to that module. You also need to plan for network segments created within the private cloud to host VMs. You need to allocate IP space for those and think about how you're going to provide DNS and DHCP services for those. And if you're going to use HCX to extend on-prem networks, you may need to create some additional on-prem segments for HCX management, HCX uplink, HCX vMotion, and HCX replication. So we've hit on technical considerations, but we also want to think through more of the operational things. How well equipped is your organization for operating AVS? Who will own AVS? Is it the VI admins, a cloud platform team, somebody else, or a mix? Perhaps the cloud team will own creation and management of the AVS private cloud and related Azure objects, but the VI admin team will own tasks related to vCenter and the clusters within it. Give this some thought before you deploy and build your RBAC controls appropriately. There may be some overlap. VI admins may need access to the AVS private cloud object to configure features that are only exposed there. These would include things like placement policies, storage policies, and creating DHCP and DNS changes. Another thing to think about is if your existing infrastructure management tools, are they suitable for managing AVS resources? If you have a heavy Azure presence already and you're using native tools like Azure Monitor, Azure Security Center, Log Analytics, these all support AVS workloads as well. If you're using the vRealize products on-prem today, vRealize Operations, vRealize Network Insight, and vRealize Automation are all supported with AVS. Think broadly about how you can provide guardrails for end users to help control costs, minimize security risks, improve efficiency, and accelerate adoption. Microsoft has this thing called the Cloud Adoption Framework for Azure, and it has an extremely thorough methodology for introducing policies and controls aligned to what they call the 5 disciplines of cloud governance. And those include cost management, security baselines, resource consistency, identity baseline, and deployment acceleration. It's worth a close read. We're not going to try to summarize the whole thing in this series, but we will hit on a few of the more tactical tools and techniques as they relate to Azure VMware Solutions specifically in future modules.
So to recap, here's the things that we covered in this particular segment. First, you got to know your use case, right? Looking at the 5 use cases and beyond, what are you going to be sizing for? What is the purpose of deploying your private cloud for? Next, we decide where and how much we're going to deploy. So this is talking about what regions, do we need to be close to certain users or certain geographical locations? And how large do we need to make our private cloud? What kind of workloads are we going to host there? Next, we need to understand our connectivity options, whether that is using a site-to-site VPN, whether that's using ExpressRoute, and some of the other connectivity options that you can leverage within Azure. And then lastly, thinking about day 2 operations and beyond. How do we manage the day-to-day after the fact? What do we do with our workloads? How do we monitor, handle logging, backups, et cetera? Next up, we're going to go through a demo of an initial AVS deployment and look at the connectivity from our lab on premises out to Azure VMware Solution Private Cloud.